Welcome to Dr. Physics Coder YouTube channel. I hope you like our videos and considering subscribe our YouTube channel. I am your friend today to highlight Indian nuclear physics program past and present scenario. Please close your eyes and feel the Properous India and feel proud for Indian science and technology. I will start Indian nuclear physics journey from 1940s, the birth of the Indian nuclear program, an era marked by ambition and foresight. At the epicenter of this narrative, a pivotal figure emerges, Homi Jehangir Bhabha, a man enriched with enormous intellect and visionary ideas. A proud alumnus of Cambridge, Bhabha returned to his motherland amidst the turmoil of the Second World War, nurturing a fiery ambition to lay the foundation of nuclear physics in India. With a keen awareness of the untapped potential of atomic energy, Bhabha dared to channel it for the progress of his nation. His vision was holistic and multidimensional, extending beyond the mere generation of nuclear power. He imagined a future where nuclear technology would revolutionize sectors like agriculture, medicine, and industry, propelling India towards a new era of development. Manifesting this vision, Bhabha established the Tata Institute of Fundamental Research, or TIFA. Situated in the bustling heart of Mumbai, TIFA emerged as a lighthouse of scientific exploration, inviting inquisitive minds to delve deep into the complexities of atomic particles and the nucleus. In Bhabha, laid the groundwork for a culture of scientific inquiry, not bound by conventional thinking, but driven by the quest for knowledge and innovation. Yet Bhabha's ambitions were not satiated. He took a giant leap further by establishing the Atomic Energy Commission of India. This institution, operating directly under the Prime Minister, was entrusted with the responsibility of devising policies related to nuclear energy and guiding its evolution in India. The Atomic Energy Commission became the linchpin of India's nuclear, molding it with a defined sense of purpose and direction. Bhabha's relentless efforts were instrumental in shaping India's nuclear physics program. His institutions became the nurturing ground for nuclear research in India, crafting a generation of scientists and paving the path for future breakthroughs in nuclear technology. Thus, the seeds of nuclear physics in India were sown with the establishment of these monumental institutions. The roots laid by Bhabha were deep, the foundations sturdy. From this emerged a robust tree of nuclear science, its branches reaching out incessantly towards the skies of progress and innovation. But how did India's nuclear physics program sprout from its early roots, you may inquire? The response is encapsulated in a narrative of tenacity, ingenuity, and an undying dedication to peaceful scientific evolution. The adventure initiated in full swing in the mid-1950s. Specifically, the year was 1956, a cornerstone period in the chronology of Indian nuclear chronicles. This was the year when the first research reactor, named Apsara, materialized. Constructed under the guidance of Dr. Homi J. Bhabha, India's nuclear father, Apsara was not just a mere reactor. It was a symbol of aspiration, a lighthouse of scientific inquiry, and a proof of India's burgeoning scientific clout. The birth of Apsara initiated a thrilling new epoch. Utilizing an indigenous, heavy water-moderated design, it marked India's first steps into the world of nuclear reactor technology. Yet the significance of India's nuclear program extends beyond Apsara. In 1969, the Tarapur Atomic Power Station was built, becoming India's first commercial nuclear power station. With an initial capacity of 320 MW, Tarapur showcased the potential for nuclear power to meet India's growing energy needs, furthering India's commitment to exploiting the benefits of nuclear energy for peaceful purposes. Both Apsara and Tarapur served as testaments to India's commitment to peaceful nuclear energy. India's nuclear energy program has been characterized by a steadfast commitment to using nuclear power for peaceful means, as affirmed by the No First Use policy. India's nuclear endeavours are firmly rooted in the ambition to use this power for electricity generation, medical applications, and other peaceful purposes, emphasising the balance between harnessing nuclear power and maintaining international peace and safety. Yet, this was merely the inception of a voyage that would encounter a balanced mix of hurdles and victories. Ever wondered how the Indian nuclear program navigated through the swirling tempest of global nuclear disarmament pressure? Journey back with us now to the pivotal year of 1974. It was during this year that the Indian nuclear program, shrouded in secrecy under the intriguing moniker Smiling Buddha, successfully executed its first peaceful nuclear explosion. Globally, this development was met not with the same serene smile, but with shock and apprehension. The international community voiced a strong outcry for nuclear disarmament, vehemently challenging India's nuclear advances. India, however, remained unyielding in its stance, reinforcing that its intentions were purely peaceful. The global community remained dubious, their skepticism unassuaged. In reaction to India's audacious nuclear test, the Nuclear Suppliers Group was formed. This organization, composed of nuclear supplier countries, exacted rigorous export controls on nuclear materials and technology, a strategic step tailored to curb nuclear proliferation. However, this move also had another significant consequence. It left India ostracized from the global nuclear fraternity. Moving forward, we come across another watershed moment, Operation Shakti. This series of nuclear tests in 1998, conducted discreetly in the Indian desert, further tightened the grip of international sanctions and embargoes on India. This made the country's journey of nuclear self-reliance more arduous than ever. But India, with its trademark tenacity, refused to bend to this pressure. Instead, these challenges only seemed to fuel India's determination. The nation pressed on with its nuclear program, redoubling its efforts and concentrating on self-reliance and indigenous development. India steadily overcame the imposed challenges, sidestepping the sanctions and embargoes, and finding innovative ways to source the necessary materials and technology. The path may have been studded with obstacles, but the country's relentless pursuit led it to become a formidable player in the global nuclear arena, all the while maintaining its pledge to use such power solely for peaceful purposes. So, when precisely did the globe sit up and acknowledge India's nuclear prowess, you might wonder? We need to rewind history back to 2008 to find the answer. A year etched in gold letters in the annals of India's nuclear physics program. And the reason, the Indo-US nuclear deal's inception, a transformative agreement that drastically redefined India-US diplomacy and amplified India's nuclear stature on the international stage. This accord was not a mere diplomatic handshake, it was a powerful symbol of the world's largest economy, acknowledging India's prudent and responsible conduct in the highly sensitive nuclear arena. The Indo-US nuclear deal was a key that unlocked the previously closed doors for India to partake in nuclear commerce. Earlier, due to sanctions imposed following the nuclear tests in 1974 and 1998, India's participation in nuclear commerce was significantly restricted. However, the Indo-US deal didn't stop there. It didn't just lift those curtailing sanctions, it did something far more impactful. It sparked a profound shift in the global nuclear order itself. India, once seen as a nuclear outcast, was now viewed through a new lens, a responsible nuclear power that could be entrusted with sophisticated nuclear technology. The Indo-US nuclear deal's influence can't be overstated. It led to an increase in India's uranium reserve, crucial for both power generation and strategic needs. It boosted India's quest for clean energy and opened avenues for collaboration with other countries, enhancing India's geopolitical and strategic ties. It also paved the way for India's membership in the Nuclear Suppliers Group, NSG. The deal was indeed a turning point in India's nuclear journey, a journey that turned India from a nuclear pariah to a responsible nuclear power, gaining the world's trust and respect. What does the future hold for India's nuclear physics program? This intriguing question reverberates from the arid deserts of Rajasthan to the dynamic urban landscape of Delhi. The answer, it seems, is deeply rooted in the nation's audacious scientific plans and technological prowess. A closer look reveals a more detailed picture. The cornerstone of India's future nuclear strategy is its on thorium-based reactors. India, being the custodian of the world's largest thorium reserves, is leveraging this plentiful resource to create a sustainable energy path. But this thorium-centric methodology is not merely about tapping into a native resource. It is about building a safer, cleaner, and more efficient nuclear energy framework. Thorium reactors, with their low waste generation and high energy output, emerge as a beacon of hope for the world's insatiable energy demands. Indeed, India is gearing up to spearhead this revolutionary shift. However, India's nuclear physics program's future vision extends well beyond thorium. The nation is also delving into the possibilities of nuclear fusion. the very process that fuels our sun. This realm isn't devoid of challenges, but the allure of fusion energy is simply too compelling to resist. It offers a nearly infinite energy supply, coupled with minimal repercussions. India is pouring colossal investments into this area, emerging as a key player in international fusion research initiatives. The road ahead, though, is fraught with scientific and technological obstacles. Fusion research is inherently complex and requires collaboration on a global scale. While thorium reactors promise a safer alternative, they come with their own set of challenges, such as developing the technology for successful and scalable operation. The path to harnessing nuclear energy effectively is a daunting one, but India's nuclear physics program stands ready to confront these challenges head-on, armed with unwavering resolve and scientific innovation.